The first unique aspect of Uranus is its name. All the planets are named after Roman gods except Uranus. It's named after the Greek god of the sky, Uranus. The Latinized version of this word is what we use today. Had they just kept the Greek version, it might have saved a bit of embarrassment as people stumble over saying Uranus in a polite way. It even has two ways to pronounce it, as no one has been able to definitively agree on the matter: Uranus and Uranus. Uranus is also very special in the way it rotates and orbits. It is the 7th planet from the Sun, the second from last planet. It orbits on average around 19.2 astronomical units from the Sun, which means it is over 19 times further away from the Sun than our Earth. This varies throughout its year by 1.8 astronomical units, the biggest difference of any planet. Being this far away from the Sun means it is freezing cold, minus 220 degrees Celsius cold, which makes it the coldest planet in the solar system. Its year lasts 84 Earth years. When it was first discovered, astronomers attempted to predict its orbit. After some time though, they realized it hadn't followed their predictions, and concluded that the reason was because there was another planet that had a gravitational influence on it. They mathematically predicted where this planet should be, and as a result, Neptune was discovered. Interestingly, the same theory surrounds this as yet undiscovered Planet X or Planet 9. Some far out objects in our solar system are not where they should be, and theory suggests this is because of another planet that has a gravitational influence on them. The hunt is now on to actually find this planet. What's really interesting about Uranus is its rotation. Most planets rotate like a spinning top on the table of the solar system plane. Not Uranus. No, Uranus has fallen over and is rolling instead for large portions of its year. You see, its axial tilt is 97 degrees. This means its seasons are crazy in comparison to the rest of the planets. During its solstice, or the time of year when the sun is highest or lowest in the sky, one hemisphere of the planet always faces the sun, while the other is in complete darkness. It kind of looks like the planet is rolling along its orbit. Only a very narrow strip near the center of the equator of the planet experiences day and night during this time, but the sun does only just rise above the horizon. The poles, on the other hand, get 42 years of continuous darkness, followed by 42 years of daylight. During its equinox, which is the opposite of a solstice, the planet has a more normal day-night cycle. Uranus is currently leaving its equinox, having passed it in 2007, and is now heading back towards a solstice. Uranus rotates once every 17 hours and 14 minutes. Because its surface is not solid, however, some parts of the atmosphere rotate faster than others, and due to high winds, some sections can make a full rotation of the planet in only 14 hours. This strange rotation and axial tilt means it is the only planet in the solar system that gets more energy from the sun at its poles than at its equator on average. For some reason though, the equator is hotter than at the poles, and no one really knows why. Speculation also exists as to why Uranus rotates the way it does in the first place, although it is generally accepted that a large Earth-sized planet crashed into Uranus, knocking its rotation on its side. How big actually is Uranus? Well, it is the least massive of the gas giants at 14.5 Earths compared to Neptune's 17 Earth masses. Its diameter though is just bigger than Neptune's at 50,700 kilometers, about 4 times more than Earth's. Because this mass is spread out over a large area, the gravity on Uranus is only slightly less than on Earth, at 7.8 meters per second squared, or 0.89 Gs. That would feel quite comfortable. And what is it made of? Well, it is believed to have a core just smaller than Earth of rocky silicate material, which is surrounded by a mantle of water, ammonia, and methane ices. Although it's referred to as ices, this mantle is in fact very hot, reaching almost 5,000 degrees Celsius, and is more like a liquid ocean surrounding the core. So, to call Uranus a gas giant is a bit disingenuous. It is certainly not gaseous all the way through. The atmosphere is in fact very insubstantial in comparison, only consisting of a total of 0.5 Earth masses, with most of the mass of Uranus being in this core and mantle. The atmosphere is comprised of mostly helium, hydrogen, and 2.3% methane, and then a cloud layer on top. It's this methane that gives Uranus its aquamarine or cyan color. Very interestingly, some models suggest that pressure at the base of the mantle on Uranus is enough to break the methane molecules apart, which then compresses the carbon atoms from the methane into diamonds. These diamonds rain through the mantle like hailstones. The very base of the mantle could be a layer of liquid diamond or carbon with solid diamond bergs floating in it. We'll fly away from the planet just a little bit now to have a look at its planetary ring system. Uranus, much like the other larger planets in our solar system, has rings. It has 13 very dark and young rings. Most are not bigger than a few kilometers wide, and they are thought to only be 600 million years old, much younger than Uranus. They are comprised of extremely small particles, the biggest being only a few kilometers across, made of water ice and dark radiation processed organics. Their albedo doesn't exceed 2%, or in other words, they are darker than wet soil. As we'll see shortly, Uranus has a lot of moons, and the rings are thought to be the result of high-impact collisions with some moons in the past. It is unclear why some of the rings are kept so narrow, the usual explanation being that the rings are kept in line by shepherd moons, but this is only the case for one of the rings here. Uranus was discovered to have rings in 1977, when an occultation of a star occurred. The star dimmed a few times on either side of Uranus as Uranus moved in front of it, confirming the presence of rings. Uranus has only been visited by spacecraft once, and that was in 1986 by Voyager 2. Voyager 2 discovered a lot of the rings and moons of Uranus, giving us close-up shots of the faint ring system. When Voyager flew by though, this only brought the total of known rings to 11. When Hubble was launched, it also had a look at Uranus, discovering 2 additional rings that had never been seen before. The outermost ring is twice as far away from Uranus as the previously thought outermost ring. And as promised, here is a look at the many moons. Unusually, the moons are named after figures in English literature. Overall, Uranus has 27 known moons divided into 3 categories. The 13 inner moons, 5 major moons, and 9 irregular moons. The inner moons are connected with the rings of Uranus, some of which may have provided the ring's materials. The largest of these moons is called Puck, at only 162 kilometers in diameter. It is the only inner moon to be captured in detail by Voyager 2. Interestingly, these inner moons constantly perturb each other, and the system is very unstable. There's a good chance that some of them may collide again in the future. The 5 biggest moons, in order of distance from Uranus, starting on the left, are Miranda, Ariel, Umbriel, Titania, and Oberon. Titania is the largest moon of Uranus and the 8th largest moon in the solar system at 1,600 kilometers. Again, as can be seen, these are very dark objects, Umbriel being the darkest. With the exception of Miranda, which is comprised mainly of water ice, the rest are thought to be a mix of water and rocky materials. These moons may have differentiated interiors, meaning a core of rocky material with a mantle of ice. Between the core and the mantle could well be an ocean layer of liquid water. Interestingly, the axial tilt of the large moons is the same as Uranus, meaning that during solstice, if you were to look at the sun, it would only ever move in a circle in the sky, never setting. During solstice, only one side of the moon faces the sun, meaning a constant daytime. The final 9 known moons are irregular moons. They are likely to be captured objects and are much further out than the last of the big moons, Oberon. They vary in size from 20 kilometers to the biggest, Sycorax, which is about 200 kilometers in diameter. Finally, let's explore Uranus's climate and magnetosphere. Uranus's seasons are quite unique in the solar system due to its exceptional axial tilt. Telescope technology has only allowed us to resolve details on the surface of Uranus for the last few decades, which means it's difficult to be able to say with certainty if there are changes between Uranian years. What has been observed though is that as the planet approaches solstice, the pole brightens and a collar forms. Moving away from solstice, the pole and collar dim. This brightness is thought to be due to the thickening of methane clouds, although the cause is not clear. Seasons also affect storms in the upper atmosphere. Storms are relatively rare on Uranus compared to other gas giants, but are thought to be caused by changes in the seasons. With the improvements in telescope technology, we've also been able to observe bands stretching around the planet, much like the other gas planets. However, these bands are mainly visible in the infrared, which is why Voyager was only able to show us this invisible light. In these infrared images, you can also see small storms dotted all over. And another unique feature of Uranus is its unusual magnetosphere. Usually, magnetospheres originate from the geometric center of the planet, but that's not the case with Uranus. Also, it's not in line with the rotational axis, but is 59 degrees off. This unusual placement means the magnetosphere is much stronger at the North Pole than at the South. One theory for this is the liquid diamond ocean could deflect the magnetosphere, or even that it is not the core of the planet that produces the magnetosphere at all, but rather the liquid mantle. The magnetosphere is about as strong as Earth's, and because of its unusual rotation, the magnetotail corkscrews off for millions of kilometers into space. So there we have it. Almost everything you could want to know about the fascinating